Hello and welcome to my YouTube channel. This is Ramani Online Mathematics. If you know you have not subscribed, please subscribe for me. Today we are going to look at implicit differentiation. Implicit differentiation. In fact, the ones that we have done previously are all explicit. So in mathematics, we have these two terms, the implicit and that of the explicit. When we say the implicit, what do we mean by implicit and what do we mean by explicit? For the explicit, we know that, let's say if I've given you y equals x squared plus 2, okay? This is what explicit means, that you have made y the subject. So in a case where one is made a subject, it is called explicit. But let's say if I have x squared y plus 2xy plus x, or let's say plus 4 equals to x. Is that okay? This is what implicit. If I ask you to make y the subject here, it will be very difficult in some cases, okay? Yes. But some people can still make it the subject. But what you are saying is that in a case where the two function or the two variable in this case is made to put together without explicitly put one aside or express one in the other, then we can say that that is what implicit. So the implicit is when all the variables under the study is what together. Is that okay? Very good. So now let's look at some examples and how we solve it. But before we start with examples, I want you to know this. If I ask you to differentiate this, we all know that we are going to have the y, the x equals 2x plus 0. Is that okay? Why is it that this y has been written as the y dx? The meaning of this is that anytime we are differentiating the dependent variable, in this case that is y. So here we take our y as dependent variable. So anytime you are differentiating y, okay, if I differentiate y, I will get 1. Then I will attach the y dx to it. So this thing you see here is like 1 dy dx. Is that okay? So in the case where I have y squared equals x squared plus 2, and you have to differentiate, this means that I'm going to have 2y, because if you differentiate y squared, that is 2y. Then you attach what? Dy dx to it. Is that okay? Very good. So what I'm trying to illustrate here is that anytime we are differentiating y or the dependent variable, what we do is to attach dy dx after you are done differentiating the y, not x, y. Take note of that. Let's look at some examples. Okay, now let's look at these examples. For each of the following curves, okay, express dy dx in terms of x and y. So we are going to express dy dx in terms of x and y. So let's start with the I. Then I'll do the I, then you try the I. Okay? Very good. So the I is saying that so now the I is saying that x squared plus y squared equals 4. So we have to differentiate this one. So this, if you differentiate x squared, we all know that it will give us 2x. If you differentiate y squared, that will give you what? 2y. Then you attach what? Dy dx to it. Is that okay? If you differentiate 4, which is constant, it will give you 0. Now, the aim here is that you have to make dy dx the subject. So let me send or take additive inverse of this 2x. So if I do that, I'm going to have 2y dy dx, okay, equals negative 2x. So dividing both sides by 2y, here by 2y, here by 2y. You see that we have our dy dx equals the 2 will go with the 2, leaving negative x over y. So we are to express the y dx in terms of x and y. So that is how it is done. This is very simple to do. Is that okay? Good. All right. Now let's look at the second example. X squared plus 2xy plus y squared equals what? 4. So we have to find the y dx and express it in terms of x and y. So for this case, we can easily differentiate this, right? This will give us 2x. Now this is product, so we need to use the product rule. Is that okay? You remember the product rule. Let's forget about the constant rule here, okay? And use the product rule. This is x and y. So for the product rule, if I make this u and this one v, then by the product rule, we are going to have dy dx, okay? For only this is equals to u dv dx plus v du dx. Is that okay? It means that our u is x, our v is what? Y. So if I differentiate u with respect to x, here will give me what? 1. Then if I differentiate v with respect to what? Y. Now if you differentiate y, what do you get? You have 1. But because it's 1, y, you attach the y dx to it. 1 times the y dx is the same thing. Is that okay? So let's go and substitute here. This means that our u is x. So we are going to have x dv. So I think this one should be dy because of what you are differentiating it with. Is that okay? So dv dy is dy dx. Is that okay? Plus, if I come here, my v is y, du dx, we had 1. So this is what we are going to get. After that, you multiply 2 by the whole of this. Is that okay? But in exams, if you do all this, you are wasting your own time. We have short way of doing it when it comes to a question like this. Okay, so let's look at it. You can only use this product rule when the function is too tedious for you to do it. Okay, so here when you differentiate this, we have x squared plus now 2 bracket open. This is how you go about it. First, you hold this x, okay? So if I hold the x, then multiply by the differential of this. If I differentiate y, I'll get what? Dy dx plus. Is that okay? Now here I will hold the y. Now I'll differentiate x. If I differentiate x, I'll get 1. 1 times y is y plus. If I differentiate this will give me 2y dy dx equals to 0. Is that okay? The differential constant, you get 0. So let me open this one to have. Sorry, I think there's a mistake. If you differentiate x squared, you get what? 2x. So let me open this. This will give me 2x plus 2x dy dx plus 2y plus 2y dy dx equals to 0. Okay, so for this matter, you can divide through by 2 so that the 2 will go away. But you realize that there is the y here, there is the y here. So let me write it together. So I'm assuming that you have divided everything by 2. You know, if you do that, the 2 will go away. So I will only have x dy dx plus y dy dx is equals to. So this and that If you take additive inverse, if I send it to the other side, I have negative x, negative y. Is that okay? Now this is dy, this is dx. Dy, dx, they are the same, so I can factorize it out. Then I'll get dy dx equals negative out x plus y. The negative negative can come out. Now when you have something like this, you can divide both sides by what? X plus y. So if you divide here by x plus y, here by x plus y, then our final answer to this question is going to be negative x plus y over x plus y. Is that okay? So this is what we are going to have. So this and that are the same, so you can cancel in there. Answer becomes negative 1. Is that okay? So here our final answer to this will be negative 1. Thank you. Now let's look at the last one. I'm saying that the where is it? The I, you can try your hands on it. So you move to the I, the 2. If x squared plus y squared equals 2pxy, where p is a constant, find dy dx, okay? So we will treat the p as constant. Okay. Okay, so this is the example I was talking about. So x squared plus y squared equals 2pxy. We have to find dy dx. So if you want to find dy dx here, first let's differentiate this. This will give us 2x. Okay. Then if I differentiate this will give me 2y. But remember there is y here, so that will be dy dx. As I've already explained to you that anytime you differentiate y, you attach dy dx weight. Is that okay? And it's equals to these 2p, all of them are constant, so I'll put that one. Now differentiate this one. Keep hold x and differentiate y. That will give you r x dy dx plus hold x. Hold y, differentiate x. If you differentiate x, you get 1. 1 times y will be y. Is that okay? Very good. So where I've gotten to now, I just need to multiply the 2p through because the p is also treated as constant. So if I do that, I have 2x plus 2y dy dx equals to 2px dy dx plus 2py. Is that right? Good. So if for this case I can you know group like terms so that the dy dx comes to one place. So here I'm going to have 2y dy dx here. Then by grouping like term, this is positive. Coming here becomes negative 2px dy dx should be equal to, this is positive additive inverse going there. Already we have 2py here. So this becomes negative 2x. Is that okay? So this is what we have. Remember there's 2 throughout. So if you divide through by 2, the 2 will go away. Now y dy dx is here, dy dx is here. So I can factorize that one out, leaving y minus px, okay? Then dy dx is equals to py minus 2x. Now for this case, all you need to do here is to divide both sides by y minus px because you want to make dy dx the subject. So here y minus px, here y minus px. So this goes with this. Y minus px can go into itself 1. So what do we have? We have dy dx, okay, equals py minus 2x all divided by y minus px. Is that okay? So this is the answer to the question. Is that okay? Dy dx equals to py minus 2x over y minus px. Thank you very much for watching. You will be looking at the next topic, which is the application of